In this video, I'm going to be talking about SAT, means, modes, medians, standard deviations, ranges, all the things they're going to ask you in those word problems about averages, comparing data sets, using bars, charts, graphs, word problems, all that. So if you are looking to improve your skills in these areas, then let's go ahead and then dig in. So I'm just going to go through each of these 5 things: mean, median, mode, range, standard deviation, talk about where you're going to see them, talk about how to find them, and be able to solve these problems on the SAT. And I'll also solve a couple of example problems. So mean is probably the one you're going to see the most, and the mean is going to be your standard average. So if they're asking you to take the average of something, it's probably going to be the mean. The way that works is they give you a data set. For example, they could give you 20, 25, 12, 12, and 9. And then they're gonna have you try to figure out what the average, the mean of those numbers are. So in order to calculate the mean, you add up all the numbers in the data set. So in this case, we have 5 numbers. You add those up, the total is 78, and then you divide by the total number of numbers in the data set. So we have 5 numbers here, so you're going to divide by 5, and that equals 15.6. So 15.6 would be your mean for that data set. Typically in these problems, they're going to be asking you to compare the means of 2 data sets. They'll give you like data set A, data set B. Most of the time they're going to have the same numbers in them, but not always. Sometimes they might be giving you a word problem or they tell you the mean of the data set. They tell you the values of, say, 9 out of 10 numbers, but they don't tell you the value of the 10th number. They ask you to be able to solve for that number, and you're going to just set it up like a basic algebra problem. Add all of those 9 numbers together plus the x value, divide by 10 numbers in the data set, and set that all equal to the mean they originally give you. Solve using algebra. Sometimes they might tell you the mean of a data set with like 9 numbers, and then they tell you that a 10th is added, and they are asking you to find what 10th number would be added in order to get an even mean or configure the mean in a certain way. And again, you can set that up like a basic algebra problem. But yeah, probably most of the time they're going to be asking you to compare the mean of data set A to the mean of data set B, talk about whether it's greater, less than, or equal to the mean of the other data set. So this is an example of a mean problem. In this question, it says the lists give the value in data sets X and Y. Which statement correctly compares the mean of data set X and the mean of data set Y? So like I was talking about earlier, this problem is comparing the means of 2 data sets. Data set X, of course, is going to be 5 plus 9 plus 9 plus 13 divided by 4, because there are 4 numbers in that data set. That's going to be number 9. The mean is going to be 9 of data set X. Now, data set Y is going to be 5 plus 9 plus 9 plus 13 plus 27. So one additional number, that means we divide by 5. So the mean is 12.6, which we can see is greater than 9. But instead of doing that the long way, in this particular problem, because the numbers in the first 4 numbers in data set Y are the same as data set X, you can see that the overall mean is going to be greater here because the final number is greater than the mean of data set X. It's going to cause the average of the data set to be higher than data set X. So at the end of it all, whether you use the numerical method or you reason it out, the mean of data set Y is greater than the mean of data set X. So see if we can find that in the problems. The mean of data set X is greater. No, that's wrong. Mean of data set X is less than mean of data set Y. Yes. The other two says the means of data set X and Y are equal, and then there's not enough information to compare the means. That is like, I've never seen that answer be correct before. So That's one thing I suggest if you're doing SAT. Don't ever pick that answer. So here is a problem from SAT practice test number 5. This has to do with means. 5, okay, I'm not going to pronounce that. 5, EI, a type of sea turtle, each have a nest. The table shows an original data set of the number of eggs that each turtle laid in its nest. So you have like turtle A, B, C, nest A, B, C, and the number of eggs. A sixth nest with 121 eggs is added to create a new data set. It's like F121. Which of the following correctly compares the mean of the two data sets? So first off, find the mean of that data set, the original one. So that's going to be 149 plus 144 plus 148 plus 136. Did that wrong? Plus 139, which equals, divided by that 5, so 143.2. And if we add all those numbers again together with that new data set number, then we have, divided by 6, 119.3. So we can see that having that new number has lowered it, which actually makes sense because you can see 121 is quite significantly lower than all the numbers up here. So again, you can kind of reason this out or solve it using a calculator. So that means that the new data set's mean is going to be lower than the original data set. Any problems, that one makes sense. So the second thing you're going to see a lot of is mode. Mode is basically finding the average of the data set by which number repeats itself the most or is most commonly found in that data set, especially in larger data sets. And the numbers that I mentioned in the data set in the previous section, mean section, I had 20, 25, 12, 12, and 9. And you can see the only number, in fact, that's actually repeated is 12. So the mode in that case would be 12. So oftentimes you're going to be seeing this type of problem, again, comparing data set A to data set B and asking where is the mode greater, where is it less than or equal to across the sets. The third way that you'll see data sets finding averages is through the median. The median is just the middle number in the data set. And so you're, in that case, going to arrange all the numbers in the data set by numerical order. So as I mentioned in previous problems, it would then become 25, 20, 12, 12, and 9. And you're going to count and take the number in the middle, and that's going to be your median. So 25 on one end, and you have 9 on the other, then you have 20 and 12, and then you have 12 smack dab in the middle, so that would be your number. If you have a data set that has an even number of numbers, like 6 numbers in it or 8 numbers, then you're going to take the mean or the average in between the middle two numbers. So if you have 6 numbers, you're going to take the mean of number 3 and number 4. So add those together, divide by 2, and that's going to be your median. Typically, again, you're going to see this in problems involving comparison of data set A to data set B. The problems that I'm talking about in this video that involve algebra are typically going to be those mean problems. So the fourth type of problem is standard deviation, and this one you don't really ever have to derive in the SAT. It's almost solely, in fact, I've never seen one that actually asks you to derive it because you don't really have to do that in high school math. They just ask you to visually decide what data set has a greater, equal, or smaller standard deviation. So if you're looking at two charts kind of like this, then you're going to look at them and try to figure out where are the numbers most spread out from the mean. In this type of problem, you may have to calculate the mean of the data set, but probably not. You're just going to generally look at the middle and figure out the data set that has numbers most spread out is going to have a greater standard deviation because it deviates more greatly from the mean. The numbers that are clustered closer together to the mean or the middle are typically going to have a smaller standard deviation. They deviate less from the average of the data set. So it's really by a visual basis they're going to be able to decide this. The fifth problem type is the range, which is pretty simple to calculate. You just take the highest number in a data set and the lowest number in a data set, and you find the difference. So in the data set again that I mentioned earlier, you'd have 25 and 9. 25 minus 9 is 16, so the range in that data set would be 16. Again, this is often going to involve comparing data set A to data set B. So here is a problem involving medians. Let's go ahead and read the problem. As you can see, this is a chart this time instead of just a list of numbers. The dot plot represents the 5 values in data set A. So each one of these dots is a value. So you have 5 values of 22 here, 4 values of 23, etc. Data set B is created by adding 56 to each of the values in data set A. So 56 to this one here, 56 to this one here, 56 to this one here. Which of the following correctly compares the medians and the ranges of data set B? So I guess I was wrong originally. This problem is comparing medians and ranges. So as I mentioned earlier, to find the median of a data set, you're just going to find the middle number, which is probably going to be in this section, I'm guessing, based on how here's the numbers are spread apart. So add 56 to that, and that's going to be the median of data set B. The range is the top number minus the bottom number, so in this case it's going to be 4. If you add 56 though to all the values in this data set, the range is still going to be 4 because it's the difference between the two values and doesn't actually have anything to do with those values themselves independently. So the range is going to remain the same across those two data sets, while the median is going to increase in data set B. So that's going to be somewhere our answer. The median of data set B is equal, no, we already said that's not the trick case. The median of data set B is equal, no, we already said that no. The median of data set B is greater than the median of data set A, and the range of data set B is equal to the range of data set A. That's what we were saying. So we can ignore the following problem and continue working through problems. So with these types of problems, you're typically going to be required to know many of these forms. Like you're going to be asked about range, median, and mean all in the same problem, and you're going to have to know the difference. Sometimes you won't have to actually work the numbers out and solve them for yourself, and you can eyeball it. Sometimes you do have to get in the nitty-gritty and actually be able to solve it, aside from standard deviation. So I'd really suggest that you practice using Khan Academy, other resources, these types of problems, so you can get confident quickly being able to look at a problem and knowing how to solve it, visualize what's going on using the charts and graphs so that you can speed through these problems on the SAT. If you enjoyed this video and you found my overview of what the practice problems are and my practice problems that I walked you through helpful, if you did, then please like and subscribe. Also, feel free to leave comments below suggesting ideas for future videos, because I'm always open to making a video specifically for you. And please keep in mind, this is also part of my college application process, just like the SAT is a part of yours. And more engagement on my channel helps me out to make this a bigger part of my activities section. So anyway, with that said, I hope this video on range, standard deviation, median, mode, mean, all those things, averages, helps you a lot and helps you to get a great SAT math score. So thank you so much for watching, and I'll see you again soon.